Hi and welcome. In this video, we are going to implement two stacks in one single array. The operations that we need are push1, pop1, print1 for stack 1, push2, pop2, print2 for stack 2. Okay. As we all know, the stacks will follow the last in first out operation. Okay. So this is nothing but a stack. We have to implement two such stacks. Okay, that follows last in first out operations. Obviously, we will have top 1 for the first stack and top 2 for the second stack. Okay, now inside an array, how to do it? Inside an array, how to implement a stack inside an array. So you're given this array of size 10. Okay, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine, size 10. I want to implement two stacks inside this array. So one of the most basic approach here is nothing but divide this array into two parts. Okay, into two halves. Now first half is for the stack 1 and the second half is for the stack 2. Now it's choice how we are going to implement it. So if this is my top 1, okay, and this is my top 2. So insert the elements one by one, increment the top. So finally when we insert the elements, so top 1 will be here and top 2 will be here. Correct? Now if I insert it any element again, so it will give me overflow. Stack 1 will give me overflow after this point, because now all the elements are completed, all the spaces are full. Okay, now stack 1 will give me overflow. Okay, and now if I insert in T2 after this, it will give me overflow if I have now push operation on T1. Okay, on stack 1, now it will give me an overflow because we have no other space left. And similarly for push operation on T2, it will give me an overflow because we have no other space left. So given a size of the array n, okay, for stack 1 we give the first 0 to n by 2, fine, and from n by 2 to n we give the next one, n by 2 plus 1 to n we give the next one, and minus 1 if we are following the index formulas. Okay, so this is how you are going to do it. Correct? It's okay, it's fine. Now after this, but here it is not a space efficient method. This is simple because we all know the push and pop operations. Okay, so we all know about the underflow and overflow conditions also. So we can manage all that. We can just simply write a push pop operation. Whenever we push, we will increment the top and we will insert at that element at that top position. Then when we push, we increment the top and we insert there. When we pop, we decrement the top and pop the element. So this is what we do. This is what we already are doing. Okay, but this here is not a space efficient method. Why I am saying this? So let's suppose T1 is full. T1 is full. Okay, but there is no element in T2, but there is no element in the stack 2. Stack 1 is full, but there is no element in stack 2. Now if I want to push one more operation, one more element, if I want to push one more element in stack 1, okay, let's suppose 60. We have space in the array. We have space in the array, but now T1 will say overflow because T1 reaches n by 2 its maximum capacity. So T1 will say that it is overflow. That is, stack 1 will say it is overflow. Correct? But we do have space left. We do have space left for T1, for stack 1 in the array. We do have space left. We have 1, 2, 3, 4, 5 more elements. We do not need stack 2. Let's suppose we just need one of the elements in the stack 2 and nothing else. Just one element in the stack 2 and 9 elements stack 1. But we cannot have this implementation right now because we have not provided 9 space to stack 1. We have only provided n by 2 space. Okay, we have restricted the stack. Therefore it is not space efficient. Okay, we have to actually make it space efficient. That if I say x element should be in stack 1 and y element should be in stack 2, so according to that I should get the overflow and underflow conditions. Okay, now if x is greater than y1, if x is greater than y1, that there are more elements in stack 1, okay, more element than the n by 2 space, then also it should be possible to insert one more element here. Okay, now stack 1 boundary should be this. Okay, it should increment. Fine, if there are space left inside the array, it should increment. Okay, similarly for stack 2 also. Now if we reach a place where stack 1 and stack 2 both are full and it is space efficient, then we can say overflow or underflow conditions. Correct? But here right now, if we do not do this and if we just have n by 2 elements for stack 1 and n by 2 for stack 2. Now we have restricted both the stacks. Okay, if we just want one element in stack 2 and all other elements in stack 1, we cannot have that. We cannot have that implementation using this method. Okay, so this method fails in this particular scenario when we have dynamic stack push. Okay, that we need to push more elements in stack 1 than stack 2, or more elements in stack 2 than stack 1. Fine. So let's see the method 2 now, in which we will have a dynamic implementation. That means we will see that if I want to insert some elements in stack 1 and some elements in stack 2, then how it will work out. Let's see that method. So let's see another implementation now. Now given the array, okay, we will begin the stack 1 from the leftmost element, that is the 0th element, 0th index, and the second array from the last element, that is the 9th index in our example. Okay, now let's perform some operations. So if I perform p1 2, so that means 2 will be inserted. Fine. So 2 will be here. Okay, now as we know, in the beginning t1 value is nothing but -1. Okay, t1 value is nothing but -1, and t2 value is nothing but equal to the size of the array, that is 10. Fine. So I am performing push and pop operations, simple push and pop operations. t2 is nothing but size and t1 is nothing but -1. Okay, now when we perform push 1 on 2, so how push is operated? So it is nothing but push 1. So first it will be array of plus t1 equals to the data that we want to push, correct? So first t1 will be plus, so t1 will now point to here, and now 2 will be pushed inside. Okay, so now 2 is added. Now what if I have p2 of push 2 of 3? Okay, now I have to push 3 in the second stack. So first t2 minus will occur. Okay, minus t2, then we will push t2 minus will give me this one, so t2 will be here. Now push at this position, at this array of t2, the data. Okay, so now 3 will be inserted right here. Fine. Now again, if I have p1 of 4, so first t1 will be incremented, so t1 will point to this. Okay, and 4 will be inserted. Similarly, if I have p2 equals to 5, so now t2 will be decremented, so t2 will be here and 5 will be inserted. So this is how push operation will take place in both of the stacks. But how do we know that which we have space left? How do we know this position? So let's see. Let's suppose t1 reached at this position by adding the elements 6, 7, 8, okay, 9, and t2 reached at this position by adding 3 again. So we have 1, 2, 3, 4, 5, 6 elements in stack 1 and 1, 2, 3 elements in stack 2. Fine. Now I am going to add one more element in stack 1, let's say 10. So how do I know that the space is remaining, It is actually very simple. Okay, we will use that how many spaces are there between the t1 and t2. We will use that formula, that between two ranges how many elements can be there. So for example, if I have 2 and 5, so inclusive 2 and 5, how many elements are there between 2 and 5? So how do we find that out? It is nothing but 2, 3, 4, 5, that is 4 elements can be inside the range 2 and 5, including 2 and 5. So what is the formula? Upper range minus lower range plus 1. Okay, 5 minus 2, 3 plus 1, 4. Similarly, when we see here, it is nothing but t2 minus t1 plus 1. So how many elements can be there between t1 and t2? 3 elements are there between t1 and t2. Okay, now t1 and t2 already have their own elements, so how many elements are remaining? That is nothing but 1. Okay, so just a single space is remaining. So how we will find that part out? So it is simply nothing but when t2 is greater than t1 plus 1. Okay, now t1 plus 1 should be greater than t2. t2 should be greater than these two values, that is t1 plus 1. So t1 is 5, 5 plus 1 is 6. t2 is still greater than 6, that means element a space is remaining, 10 will be inserted and t1 is here. Now if I go to p1 of 11, now again it will check, is t2 greater than t1 plus 1? So what is t2? t2 is nothing but right now 7, t1 is nothing but 6, so 6 plus 1 is 7. Is this condition true? No, it is not true. That means we cannot add more elements in t1. Similarly, that is stack 1. Similarly, if we check for T2, it is nothing but, what do we need to check? The same condition? Yes, the same condition. That is T2 is greater than T1 plus 1. If this condition is true, we get our answer. You can reverse this condition also. That is nothing but using T1. If T1 is less than T2 minus 1. If T1 is less than T2 minus 1. Okay. As soon as till this condition is true, okay, till this point, we can add the elements in T1 and T2. As soon as this condition becomes false, we cannot add more elements and we need to give overflow condition. Okay, you can take many more examples to test this out. Okay, let's see. So if T1 is here and T2 is here, T1 value is 4, T2 value is 7. Can I add more elements? So just check, is T2 greater than T1 plus 1? 4 plus 1 is 5. 7 greater than 5? Yes, that means more elements we can add. Similarly, you can check for this condition also. That is, these are the same. T1 is less than T2 minus 1? Yes, it is. Now if T2 is here, let's suppose T2 is here, and we need to check whether our space is remaining or not. So is T1 less than T2 minus 1? T2 is 6, 6 minus 1 is 5, T1 is 4. Yes, 4 is less than 5, so that means our space is still remaining. Okay, so this is how we are going to check for the overflow condition. And for the underflow, it is very direct. When T1 is less than 0 and T2 is greater than the size minus 1. Okay, when T2 is greater than size minus 1, that means we have no other elements left. Okay, so if we start popping out, the elements one by one, T1 will come here. Okay, T1 will come here. Now if we pop T2 also, T1 will become minus 1. So as soon as T1 becomes minus 1 and one more pop operation occurs, we can directly say that underflow error is there. That means there are no more elements left inside the stack 1. Okay, similarly for T2, if I start popping the elements, and T2 reaches this position and we pop the last element also, T2 will become again equal to the size. Now if we pop one more element, it will say that T2 is already equal to the size. We have no more elements left, so simply pop. Okay, so for push and pop, these are the conditions for underflow and overflow, and we can directly add and subtract from push and pop directly. That is a common thing. Okay, so for push, we will just simply check this condition, okay, whether it is overflow or not. If it is not overflow, we will increment the T1 or decrement the T2 depending on the stack, and we will add the elements. Okay, so as we know, as we have just seen, for pushing we have to increment T1 for stack 1, and for push in stack 2 we need to decrement T2 from the end to the first element. Okay, so for T1 will be incremented, T2 will be decremented for push operation. For pop operation, obviously it is just the opposite. T1 will be decremented and T2 will be incremented for pop operation. Okay, so these are push and pop operations, underflow, overflow for this particular scenario. Fine. Now this was the logic for this particular question of two stacks inside a one single array. Okay, next we will see the implementation and what are different things that we are going to need in the implementation. Okay, I hope you understood all this, how we are going to write push operations, how we are going to write pop operations. Okay, print operation is direct, so we will discuss it in the implementation part only. Okay, for just for the revision purpose, if you guys need, so if push operation is nothing but we need to check for the overflow condition, okay, which is nothing but this only. And after we check for the overflow condition, if it is in stack 1, okay, we will need to increment T1 and add. If it is stack 2, we need to decrement T2 and add. Okay, for push operation it is exactly opposite. Check for the underflow condition. Okay, if it is not underflow, then for stack 1 we need to decrement T1, and for stack 2 we need to increment T2. Okay, so as you see, they go exactly in opposite directions. Okay, for push also they are going in opposite direction, for pop also they are going in opposite direction. Okay, you just need to think that in which direction a single stack 1 and stack 2 is moving out. Okay, for using that we will increment or decrement. So this was the logic part of this particular question. Next we are going to see the implementation part. Okay, how we are going to implement and what are the different things that we need. Okay, then we will go to implementation of coding. First we will see algorithmically that which are the things that we need to implement. Okay, so let's begin with the implementation. Now in this one, what do we need? Okay, so I will be creating a stack array class, another class of stack array. Okay, now in that class we will have all the operations that we need. Obviously push 1, pop 1, push 2, pop 2, and print 1, print 2. Okay, in the beginning we will have a constructor Fine. This constructor will dynamically create the array that we need. Now if the user wants to create an array of any size, so we will take an input. Okay, we will pass this input into the constructor, and this constructor will create a dynamic array for that. Okay, into our stack array class. Now in the main class, that is in the main function, now here what do we need? We will have our input n. Okay, we will pass this, so an array will be created. Okay, and all the variables will be initialized, that is size, top 1, top 2, and everything else. Fine. Now after this we will take two more inputs, that is stack 1 and stack 2. That means it will say how much elements the user wants to add in stack 1 and how many elements the user wants to add in stack 2. Fine. Now obviously the stack 1 plus stack 2 should be less than equal to the n. Okay, should be less than equal to n, so that all the elements are inserted perfectly. But if they are not, that means we will get the overflow error. Fine. If they are not, if this condition is false, we will get overflow error. Okay, fine. After this we will take all the inputs, that is s1 plus s2 inputs, stack 1 plus stack 2 number of inputs, and we will start pushing them into the stacks using the functions and the operations that we are going to implement in stack array class. Fine. After this, if this condition is true, that means s1 plus s2 is less than equal to n, we will not get an overflow, so we will create an artificial overflow. Okay, we are going to print both the arrays, print1 and print2 functions will be called. Fine. Then we are going to perform the pop operations. Okay, and in this we are going to see the underflow conditions as well. Fine. So this is the whole implementation that we are going to follow for this particular code. Okay, so let's create a stack array class. Okay, create all the operations, the constructor, and in the main let's see the inputs, all the inputs, and pass the inputs into our stack array class functions. Fine. Let's begin with the coding part now. So let's see the implementation now. Now here we have our n input and a class of stack array. In that class we have size, top 1, top 2, and the array itself. Now whenever we pass the n input that we have taken from the main, okay, using the object of the stack array class, we will pass in the constructor. Okay, a new array will be created. Then size equals to n, top 1 equals to -1, and top 2 equals to size, which was initialized by n. Okay, so we all have the basic needs that we need in the stack array class. Now let's implement the push function, pop function for both of the stack, print1, print2 also for both of the stack. Okay, let's do that now. So void push1, okay, and int data. So to push we need to check for the overflow condition. So if top 1 is less than top 2 minus 1 that I've explained, okay, we need to push. So array of what, plus plus top 1. So first we need to increment the top 1 and then we need to push. Okay, equals to data. Now if this is not true, else we can simply print out that stack 1 is in overflow, stack 1 overflow. Okay, so this was the push1 function. Easy, correct? So now just have the same thing for push2 also. Now in push2 here we'll have exact same thing, but obviously from 1 we will change everything to 2. So top 1 is less than top 2 minus 1, this is correct, and increment here top, sorry, we will not increment top 2, we will decrement top 2, correct? From size to size minus 1, we are going in reverse function, correct? Reverse manner. And if it is else, then we have to do stack 2 overflow. So this was push and pop for both of the stacks. Now let's see void functions. So sorry, pop functions. So pop 1. Now here in pop we need to check for the underflow condition. So top is greater than -1. Till top 1 is greater than -1, we can easily pop. Okay, so int popped element equals to array of top 1 minus minus, correct? So if we have at 5 top 1, then top 1 value will first be inside the popped element and then it will be decremented. Okay, therefore post decrement. First we have pre-increment, here it was pre-increment, and here it is post decrement. Okay, first the assignment operator will work and then the decrement operator will work. Okay, now after this we will just print out the popped element. So stack 1 popped element equals to simply our popped element. Okay, After this, after we have the popped element right here, so we can easily have else condition. In else condition, we will print stack 1 underflow. Okay, if top greater than -1 fails, so stack 1 underflow. So we have this. Now similarly, we will do for the pop 2. Okay, same. Now in pop 2, we need to check for what? For pop 2, we need to check for the size. That is the last one. So top 2 is less than the size. Till it is less than the size of the array, that is fine. So it is nothing but top 2 plus plus. Okay. Stack 2 topped element equals to this, and stack 2 underflow. So we have push and pop operations for both of them. Let me just implement the print operations also, and then we will go to our main method, and there we will take all the inputs and just print the outputs. Okay, let's implement the print first. Okay, so these are the print methods. Okay, I've implemented them directly because they are a normal array printing and nothing else. Okay, from top 1 to greater than equal to 0 we are printing. That is why we are moving from top 1, because it is last in first out stack. Okay, so therefore we are moving from top 1 to 0, and here from top 2 to size, last in first out. Therefore pop print 1 and print 2 like this. Fine. Now let's begin with the main method. Now we want to take the inputs of stack 1 and stack 2. In stack 1, and equals to sc.nextInt. Okay, that is number of elements user want to input in stack 1. In stack 2, sc.next. So number of elements user want to input in stack 2. Okay, int element, the element that user will provide. So for int I equal to 0, I less than stack 1, I plus plus. So here we will take all the elements that are meant for the user, sc.nextInt, that are meant for stack 1. Fine. So stack 1, stack array sa dot push 1, and we'll pass the element. So this is for the stack 1, and similarly we will have for the stack 2. So I equal to 0, I less than stack 2, I plus plus. So all the elements that user want to push in stack 2. So we have stack 1, stack 2 push operations. Then now just have the print also. Okay, stack 1 printing, and call the print operation, print 1. After this, stack 2 print, and call the print operation. Okay, sa.print 2. Now let's do an artificial overflow. Okay, so sa.print 1, sorry, sa.push 1 and push 15. If there is an overflow, it will show us an overflow error. Okay, now for the popped elements, so int number equals to sa.top 1, okay, plus 1. So this is the number of elements that we are having the stack 1, top 1, that is stack 1. Okay, so while this number is not equal to 0, we'll pop all the elements, sa.pop1. Fine, number minus minus. Now we have popped all the elements. If we pop one more element, so it should show us a underflow error now. So this was the whole method of them in main, and this was class. Let's now just run the program and see for all these inputs whether we get the correct outputs or not, or whether we have made a mistake, and then we will correct out that mistake. Okay, so here it will have 10. User have 10, has given 10, that is the size of the array is 10. Okay, in the first array he wants 7 elements, that is in the first stack he wants 7 elements. In the second stack he wants 3 elements. Okay, let's see all the inputs: 1 2 3 4 5 6 7 8 9 10. So 7 elements in the first stack, 3 elements in the last stack, and obviously when we print, it will be printed from 7 6 5 4 3 2 1. Okay, so stack 1 is 7 6 5 4 3 2 1 because last in first out order, and similarly for stack 2. Then if we are going to push one more element, there is no space in the stack 1 left, so it will give us stack 1 overflow when we push 15. Okay, then these all are the popped elements that you can see right here, 7 6 5 4 3 2 1 in last in first out order, that is this loop. And if we pop one more element but there is no other element to be left popped out, so it will give me stack 1 underflow. Similarly you can check for stack 2 as well. Fine, so this was the code for 2 stack array. Okay, 2 stack in a single array. Thank you.